Astronomers around the world are buzzing with excitement as fresh images of 3I Atlas, the third interstellar object ever observed from Earth, hit the screens. Right now, this mysterious visitor is racing through our solar system, and thanks to real-time live streams, people everywhere are witnessing the cosmic spectacle unfold. Oh wow, look at that! You can almost hear scientists exclaiming as they peer through their telescopes. These raw images, straight from the observatories, aren't filtered or polished. They're a direct glimpse at a fragment of what might have been a planet in a distant star system, a building block from a world far beyond our own. Despite the stunning visuals, mysteries abound. The sun's glare is steadily closing our observational window, making every moment crucial. Yet anticipation builds as Mars prepares for a cosmic close encounter. On October 3rd, 3I Atlas will swing past the red planet, offering NASA's Mars Reconnaissance Orbiter a front-row seat to capture unprecedented details. Meanwhile, astronomers armed with the Gemini multi-object spectrograph have been busy recording the comet in ultraviolet, blue, red, and near-infrared light. The images reveal a delicate anti-solar tail stretching over 50,000 kilometers, while the coma, once compact, is now nearly 19,000 kilometers wide. In just a few weeks, Atlas has transformed from a faint speck into a fully realized comet, tail streaming as solar radiation drives dust and ice outward. Gemini South's latest images show the tail expanding, dust and ice pushed away from the sun as the nucleus warms, a textbook display of cometary behavior that quiets earlier speculation about the object's nature. So why has the tail suddenly become so prominent? Two key factors are at play. First, physics. As the comet gets more sunlight, volatile ices sublimate faster, dragging dust off the surface and forming a brighter, broader coma and tail. Second, geometry. Back in July, the anti-solar tail was mostly pointing away from Earth, making it harder to see. Now, as the viewing angle shifts, more of the tail is projected into view, giving astronomers a spectacular visual. For those hoping Atlas might be something more exotic than a comet, the evidence is clear. The growing coma and visible tail confirm it's a natural icy body responding to solar heating. But for science, this is thrilling. This is the moment when detailed study becomes possible. Timing adds another layer of intrigue. The tail will continue to grow as Atlas approaches perihelion on October 29th, but Earth will be on the wrong side of the sun, meaning we could miss the peak visual display. The best chance to observe post-perihelion will come in December, when the comet sits about 170 million miles from Earth and viewing geometry improves once again. The significance of the tail goes beyond aesthetics. It confirms Atlas's cometary nature and opens the door to exploring its alien chemistry. With the dust tail visible, the extended carbon dioxide coma mapped, and observations coordinated between the James Webb Space Telescope and ground-based observatories, scientists are poised to study how an interstellar comet switches on, what it's made of, and how its activity ramps up as it races through the inner solar system. Adding a new twist to this cosmic story, images captured during last week's total lunar eclipse suggest that 3I Atlas may be developing a striking green tint as it continues its journey. Astronomers suspect this color change is tied to the comet's growing closeness to the sun, offering another tantalizing clue into the composition and evolving behavior of this interstellar traveler. Every new image is not just a picture, it's a glimpse into the processes shaping a visitor from another star system, reminding us just how dynamic and mysterious the universe really is. On September 7th, during the dramatic blood moon eclipse, astrophotographers Michael Yeager and Gerald Raymond captured an extraordinary sight. 3I Atlas bathed in an unexpected emerald glow. As Earth's shadow briefly blotted out the full moon, the pair snapped detailed photographs of the comet, revealing a vivid green halo surrounding the icy traveler. Scientists suggest this glow could be caused by volatile materials hidden deep in the comet's nucleus, now released as the sun's radiation intensifies. Yet caution remains. No other observers have confirmed this color change, making the findings tentative but tantalizing. This isn't the first time comets have stunned astronomers with a green hue. Last year, the Devil Comet 12P Pons Brooks displayed a vivid green as it neared the sun. And more recently, the newcomer Swan 25F showed a similar glow. In many cases, the culprit is dicarbon, a molecule of two bonded carbon atoms that emits green light when sunlight strikes it. Often this appears in the coma, the cloud of gas and dust surrounding a comet's core. Interestingly, spectroscopic studies of 3I Atlas haven't yet detected dicarbon, suggesting it may have been trapped beneath the surface ice, only now being released. Or perhaps another unusual mix of gases and dust is producing a similar green effect through unfamiliar chemistry.
Meanwhile, NASA's Fermi X mission has mapped a staggering cloud of carbon dioxide extending nearly 350,000 kilometers around Atlas. On August 6th, the James Webb Space Telescope turned its infrared spectrograph toward the comet, revealing a striking composition. Carbon dioxide dominates, with a CO2 to water ratio of about 8:1, among the highest ever measured in a comet. Webb also detected traces of carbon monoxide, OCS, and dust, but water, the lifeblood of most comets, was almost non-existent. Hubble refined these measurements, estimating the nucleus to be surprisingly tiny, no larger than 2.8 kilometers in radius, and possibly as small as 160 meters. For perspective, that's smaller than most solar system comets. Yet Atlas is venting gas at a rate comparable to a much larger comet, a snowball the size of a small town, behaving like a mountain-sized giant. Adding further intrigue, the European Southern Observatory's Very Large Telescope detected nickel gas in the coma. But curiously, no iron. Nickel and iron usually appear together, forged side by side in supernovae, making their separation here unusual. This chemical quirk hints at formation in a star system very different from our own, an alien nursery with unfamiliar processes shaping its chemistry. While these anomalies don't point to any technological origin, collectively, they paint a picture of a comet unlike any previously studied. Small, yet unnaturally active, poor in water, but rich in carbon dioxide, carrying an unusual chemical fingerprint, and traveling along an orbit suspiciously close to the plane of the planets. Astronomers have circled several key milestones as Atlas races through the inner solar system. On October 3rd, 2025, the comet will make a close flyby of Mars, just 18 million miles away. Observatories orbiting the red planet, including MAVEN and Tianwen-1, are expected to catch the dusty coma glowing faintly pink in the Martian dawn. 4 weeks later, on October 29th, Atlas will reach perihelion, skimming just 1.36 astronomical units from the Sun, about 130 million miles. Its speed will peak near 152,000 miles per hour, and Earth-based telescopes will lose sight of it, hidden behind the Sun's glare, though spacecraft at Mars and the Sun-Earth L1 point will continue monitoring its jetting vapor eruptions. Finally, on December 19, 2025, the comet will pass Earth at a distance of 170 million miles. Too far to be visible to the naked eye, but with its tail fully unfurled, offering an unparalleled opportunity for telescopic observation and study. Even as 3I Atlas drifts back toward interstellar space, it will pass close enough for powerful observatories like the James Webb Space Telescope and the Rubin Observatory to scour its coma for isotopic clues, potentially revealing the chemistry of a world that formed far beyond our Sun. Then, on March 16, 2026, the comet will make a distant flyby of Jupiter, 33 million miles above the gas giant's swirling clouds. If NASA approves a last-minute course adjustment, the Juno spacecraft could intercept some of Atlas's dust, giving humanity a rare chance to study material that has journeyed billions of years across the Milky Way. After perihelion, Atlas will leave the solar system forever, carrying with it a trail of unanswered questions and terabytes of invaluable observations. Some astronomers even speculate that this visitor could predate the Sun itself, wandering the galaxy for eons before arriving in our cosmic neighborhood. Its approach to perihelion, from October 29th through 30th, 2025, will bring it within 1.36 astronomical units from the Sun, close enough to intensify its activity, yet safely distant from Earth. As solar heat drives its gases outward, its tail will stretch ever longer under the push of the solar wind, providing scientists with a rare opportunity to witness a comet under stress. Under this pressure, comets reveal their secrets. For Atlas, the coming weeks may finally answer the questions that have fascinated astronomers since its discovery. What is it made of? Where did it originate? How has it survived so long on its solitary journey through the galaxy? In less than a decade, humanity has watched 3 interstellar objects cross our skies, each unique, each a clue to an astonishing diversity of worlds beyond our sun. But thanks to our telescopes and observatories, 3i Atlas isn't just a fleeting blip on a graph. It is a living relic of an alien world, visiting our solar system once before vanishing forever into the cosmic dark. What do you think? Share your thoughts in the comments. I'd love to hear your perspective. If you enjoyed following this celestial journey, consider supporting our work by becoming a member. And don't forget to subscribe, because this is your space to explore the universe with us.